The intuitive, easy-to-use toolsets inside Solidworks can drastically speed the design of oil and gas process equipment. Let's look at a typical skid-mounted system and see how Solidworks enables users to define new piping spools. From a vast piping library, I can simply drag and drop piping components, such as flanges, onto my assembly. These snap into position, and all I have to do is specify the size. Then I'm able to generate quick piping routes using our 3D sketching. By sketching in any direction I desire, I can connect the two flanges, from which SolidWorks automatically recognizes the required pipe diameter and minimum bend radius. It'll use these bend radii to automatically add elbow fittings. Adding new piping branches is just as easy. Here, I'll connect a smaller flange to the piping spool. I can specify the intersection point by simply choosing a location in the existing pipe run. SolidWorks can automatically connect the two locations for me, and all I need to do is modify the size and maintain desired clearances. I can either drag the pipe into place or use dimensions to size it appropriately. Pipe fittings, such as a reducing T, can be easily applied by dragging them from the library. SolidWorks automatically sizes the connection based on the piping information. Other components, such as a valve assembly, can also be included in our system. All I need to do is specify its location and drag out the style valve I desire. Let's open the new spool into its own window to take a better look. You'll notice that SolidWorks has automatically added piping elbow and has adjusted the length of each pipe to include the valve and elbow. This spool is now ready for documentation. The easy-to-use drawing interface allows me to quickly detail my design. I can easily choose the desired views and quickly generate bills of materials that list all the components, as well as the corresponding cut lengths. The views can be fully annotated. With one mouse click, I'm able to add balloons to all components in design. SolidWorks enables me to complete the detail by dimensioning the distances between pipe center lines. We can now return back to the assembly and work on a different area of the system. Many designs not only incorporate piping for fluid handling, but tubing for pneumatic control devices. SolidWorks empowers users to define tubing routes just as easily. Similar to how I defined pipe spools, I'm able to specify the beginning of a tubing run by utilizing SolidWorks fitting libraries. Again, for the fitting, SolidWorks has knowledge of tubing diameter and minimum bend radius. Again, form the fitting, SolidWorks has knowledge of tubing diameter and minimum bend radius. By specifying the destination of the run, SolidWorks automatically routes the tubing. Now here, we're utilizing bent copper, so instead of adding elbows, SolidWorks will preserve the bends and enable us to access the bend information in a tabular format. We can export this information to be used by a CNC bender. We've quickly laid out piping and tubing assemblies, so now let's turn our attention to the actual structural components. Process equipment relies heavily on strong welded frames and supports. In order to mount this pump assembly at the correct elevation, we'll quickly design a welded frame. Utilizing a simple 3D sketch, we'll begin defining the steel components. Plate steel will be used to create weldable feet as well as the platform on which the motor will sit. We simply choose the profile of the plate and utilize the sketch to define its length. Similarly, structural steel members can also be included in our design. From the profile library, we'll choose a square tubing to create the supporting frame. SolidWorks gives us full control over the position and orientation of the structural member. And an intuitive interface enables me to quickly choose the corner treatments. SolidWorks saves time by providing a powerful mirror and patterning tool. I can quickly duplicate the legs of my frame on the opposite side, providing the pump with the necessary support. Mounting features such as holes and hardware are easy to apply in SolidWorks. In fact, components can be defined to include mounting information. In this example, the pump carries with it the information necessary to automatically tap mounting holes into our newly created frame. Once the holes are created, the necessary hardware will also appear. These smart components can drastically shorten design time. Detailing weldments is easy. Cut lists are generated automatically, and similar to the piping assembly, views can be annotated with balloon callouts and full dimensions. In fact, automatic dimensioning routines can speed detailing so that fully detailed drawings can be completed in a few minutes. To conclude this demonstration, we'll look at one of the most powerful benefits of using Solidworks to define our skid system. A last-minute change requires us to raise the position of the pump assembly. By simply editing one dimension, Solidworks makes all the corresponding changes, updating the related support structures and piping spools. Solidworks, with its piping, tubing, and weldment design tools, meets the demanding needs of the process and power industry. Designs are realized at lightning speed, and design changes are easy to successfully accomplish.